Good afternoon and welcome to day two of the NCGIS conference. We are excited you are joining us today. Today's session that I'm moderating is Vital Signs, Know Your Address Numbers with Sally Vaughn with Person County. I'll turn it over to Sally in just a moment. Just a few housekeeping items. Go ahead and join that chat right there on the right side of the page, that little green icon. Go ahead and click on that and join the chat. I'll be monitoring the chat throughout the presentation and presenting those questions to Sally at the end. So feel free to go ahead and type them in as she presents and gives her presentation, and I'll make sure she gets those. I appreciate everyone joining. I would also like to let you know this session will be recorded. It will be available for replaying throughout the conference, and we'll also be making all the sessions available via the NCGIS conference YouTube channel at the conclusion of the conference. So be on the lookout for that, especially if there are some sessions you haven't been able to join that you want to, or maybe there's some information you want to replay at a later date, you'll have that opportunity. So without further ado, I will pass this over to Sally and we'll get started. So Sally, it's all yours.
Thanks, Matthew. Good afternoon, everybody. This is Sally Vaughn. I'm the GIS manager in Person County, North Carolina. For those of you not familiar with Person County, we are located just north of Durham County, up against the Virginia line. And today is winter wonderland of ice and freezing rain. So again, thanks for joining me. Today, my presentation is called Vital Signs, Know Your Address Numbers. And we'll be discussing how Person County tackled the NextGen 911 project. So to establish a baseline, before we began the NextGen project, and I'll set the stage, we're pretty lucky that our data for dispatching NextGen 911 information is pretty clean. A lot of effort has gone in over the last several years to proactively fix as many issues as possible. Our M type was loaded fresh in 2017, so it hadn't had too much time to get out of sync with our center line. Also, we're the only GIS shop for our PSAP. I know some other PSAPs, like Wake County comes to mind, have multiple GIS departments, multiple GIS editors, all inputting data into the same database. We don't have that problem. It's just myself and an analyst who are the primary editors, and for us, that is a major strength. However, with just the two of us, large projects can be a little overwhelming. And we are also a largely do-it-yourself GIS shop. Almost all of our services are in-house. The only service we do contract out is our parcel mapping. Shout out to Atlas Geographic for that. And like all GIS departments, we provide data to other software packages and systems throughout the county, as well as provide web applications and ArcGIS desktop support to users in other departments. Just a little bit more of a baseline. Prior to starting this project, our road, center line, and address data was pretty much meeting our current user needs. But we did take the opportunity that NextGen presented to add some information to those layers that we didn't have previously. Specifically, our cycling community was interested in the road surface of the roads throughout the county, so they could decide whether or not they wanted to bike down a particular road as they use one of our web applications. And we also added a few fields to help us keep track of new roads as they work through our development and approval process. And as you can see here in the map I've provided, we do also keep road data for our surrounding counties in our GIS. So we added a field to track the origin and the date stamp on that data. Major challenges. Our major challenges were maintaining the existing data while developing a new schema for NextGen. Ideally, we need to minimize the time that we have two schemas running. We also need to maintain the functionality of all of those services I mentioned and mitigate the risk involved in an enterprise-wide schema change. We were all challenged with COVID-19 this year. COVID brought us the challenge of developing and supporting a hub site for our public information efforts. We're still maintaining that hub today. And COVID also challenged our IT folks, as a lot of us transitioned to working remotely. Anytime our IT department is stressed, that stress can easily roll over into GIS. But I will say, due to COVID, I spent about 6 weeks working remotely, and those are some of the most productive 6 weeks in my career, and that is when the most of this NextGen work actually occurred. So I developed a plan of 3 primary phases. First phase being identify the operational dependencies in our existing data. Step 2 is create the new NextGen schema, put it into production, and then for us, step 3 was gain the 98% compliance. So step 1 was outline the dependencies and examine our existing schema. So I outlined our operational dependencies for each NextGen layer. So for example, our permitting software requires that the field name and the field alias for certain address fields be identical. Our CAD software requires certain columns be called certain things, and also has some rules about data types. Other operational dependencies include symbology and labels. We use the map template and published services. We also have several definition queries and fields used by widgets and web applications. We also had some requests to add information like the surface types to our road center lines, and so in that case, I added those to these spreadsheets. So this project did present a good time for us to make numerous schema changes to several layers all at once. So here's a that same spreadsheet, just zoomed in a little bit so you can see a little bit better. You can see where I documented which system was dependent on what field and how, whether it was a GIS dependency, an OSSI dependency, was it required or used in NextGen, that type of thing. So that was for our existing schema that we had in production at the time. Then I moved on to comparing the base schema provided by NextGen or provided by Geocom to our existing schema. And I was able to map out what existing fields could go into the provided data model and what needed to be added, what could be eliminated, etc. I also took a look at domain values. It's a little hard to see here, but in the right-hand column, you'll see the word pain highlighted in yellow. That pain was due to a duplicated domain name between the NextGen schema and our existing schema. And to this day, I'm not sure I've gotten that completely sorted out. So when you take a look at the dependencies document and the schema comparison document together, you basically have an outline of what could break due to schema change. That helped me outline what sort of enterprise-wide plans I needed to change template MXCs, web applications, configurations, widgets, queries, that type of thing. And again, working from home due to COVID was extremely beneficial. So it gave me hours of time every day with very, very few distractions, which is very conducive to this type of detail work. So in order to take the NextGen schema and put it into in order to take the NextGen schema and our existing schema and mash them together, I used Microsoft Access and created the tables in a personal geodatabase. There might be an Esri tool for it, but I couldn't find it, so I went old school. Once I had a suitable schema built, I appended or loaded our data into the NextGen schema and then populated information required by NextGen 911, such as the NGWID, the global IDs, the country name and the state name, and things like that. I quickly realized that I would need to repeat that append and load process, and anytime I have to do the same thing over and over again, I try to write a model or a script to handle that repeated task. So therefore, I built a multi-step model to help me through the process. And again, working from home due to COVID was extremely conducive to this type of work. Once I had a functioning model and the NextGen schema was properly loaded and populated, I zipped it up and was ready to send it to the Geocom Data Hub for a first run through. I got to this point on a beautiful Friday afternoon in late May of last year while working at my kitchen table. But unfortunately, I had left the credentials to the Geocom Data Hub on my desk at work and had planned to upload the data to the Data Hub first thing the following Monday morning back at the office. Well, that didn't happen. Unfortunately, my organization got hit with ransomware that weekend. Actually, the ransomware has been sitting in our system since February and intentionally corrupted most of our data. Needless to say, the data delivery didn't make it to GeoCom that Monday or the next Monday. And overall, I would say the ransomware event put me behind about 3 months with the NextGen project. However, the saving grace here is that I had fresh, clean copies of my most important data sets waiting for me on our file share as soon as it could be restored. And also, I'll take a moment to provide a shout out to the team at NC1Map. When our REST services and web applications went down due to the ransomware, I rebuilt our primary parcel viewer application with data from NC1Map. We had fortunately updated our parcels about a month prior to the incident, and we're able to use that data to supply in that application to the tax department, permitting, and the general public. So if you aren't participating in the NC Parcel project, you should, if for no other reason than having a disconnected copy of your own data. So the next step is about 7 weeks later, I was finally able to access the data I had exported for GeoCom. So I uploaded the data to the GeoCom data hub and set configurations for each layer. Having the column names match what GeoCom was expecting in the data hub for me was extremely helpful. So for example, the column name, ST pre-dir, street pre-directional, being able to match those up because they were so similar, I found to be very easy. GeoCom and CGIA staff, especially Matthew, were extremely helpful in this process, and it took a few tries to get it right. I would not hesitate to reach out to them again. Actually, I reach out pretty frequently to get additional help for this project. I did take screenshots of each layer's configuration for my reference later. If I had any suggested improvements for GeoCom, it would be an option to export the field mapping to a PDF or a spreadsheet somehow. So once the field mapping was complete, the first data quality report results came in at about a 92% match between the alley table and our road center lines. We also had a pretty manageable amount of critical errors, most of which were duplicated addresses that we didn't have correct unit numbers for. And I attribute that to my primary data editor. He has really been a champ for all of this. So once I knew my NextGen schema, or my schema was NextGen compliant, it was time to implement the schema across the board enterprise-wide. I could go into an hour-long discussion about how all of this happened, but that's beyond the scope of what we're here for today. But I did start putting the schema into production. I started with our dispatching software because it is easily the most picky software package we work with. And the functions of 911 are clearly very essential. So I wanted to make sure that we were meeting their needs first. For example, our dispatching software uses shapefiles, which can introduce a host of issues if you have field names longer than 13 characters. Those get truncated. The dispatching software also requires that certain fields be named certain things and have specific field types and links. And during testing, we discovered that the dispatching software and NextGen 911 have different interpretations of road flow direction for divided highways. So I did actually have to add an additional field to accommodate the difference in interpretation. So once my schema and the data loaded into that schema met the needs of our dispatching software, I moved on to our enterprise GIS. And lucky for me, at this point during our cyber incident recovery, I had access to my files and I had access to our SDE and SQL Server, but none of my end users did. Essentially, my production environment functioned as a development environment until the NextGen schema was implemented enterprise-wide. I took the opportunity to swap out the old layers with the new layers, rebuilt the replicas, added a few other layers in for good measure, all while no one was looking. With the NextGen 911 data on our SDE, I was able to rebuild MXDs that we use to publish REST services, fix issues with labeling or rendering or definition queries, referring back to the operational dependencies spreadsheet that I had created several months prior. I did the same thing for the MXDs that our tax department uses, as well as the GIS department's MXDs that we use for specific editing workflows. So soon, our organization was ready to turn our ArcGIS server back onto the public and restore our web applications. After speaking with Esri, we decided it would be best to install ArcGIS server fresh and not attempt to restore. Portions of my ArcGIS server implementation have been BitLockered, so it was not a good idea to attempt to use that again. But again, this gave us the opportunity to make some organization-wide changes while essentially no one was looking. That bought me time to reorganize REST services, test geoprocessing services. But it also meant that a lot of our REST service URLs changed. In order to make those changes in ArcGIS Online, I used something called the ArcGIS Online Assistant, which lets you find and replace old URLs for new ones. And if you aren't familiar with the ArcGIS Online Assistant, it's awesome. I provided the URL here, or you can search for the ArcGIS Online Assistant. In order to restore all of our services, I needed to prioritize web maps and applications. And I need to stay on track when doing things like that, as I'm easily distracted. So I used yet another spreadsheet, went application by application, updated the ArcGIS Online map URLs, reconfigured widgets. Unfortunately, most widgets reset themselves when service URLs change. But fortunately for me, I had an intern the previous summer who had documented all the widget configurations. So all I had to do was refer to those documents. I also took the opportunity to record which REST services were used in which web apps. This is a project I started a few years back and hadn't really kept up with it. This particular spreadsheet lets me know quickly which web apps might be affected if a specific REST service isn't working. So in the example shown, the basic parcels application uses the REST services indicated with an X. You'll also see the word need in there for a REST service that I needed to restore or republish. And moving forward, I try to revisit these two spreadsheets on a monthly basis and keep them updated. So now it's time to fix what broke. With our critical web applications rebuilt and reconfigured, but not yet public, I had a few days to fully test everything. We also had some domain issues, and our permitting software didn't like one of my field aliases. A change in field names also broke our addressing workflow, but I will talk a little bit more about our addressing workflow later in the presentation. The next step for us was to gain NextGen compliance. So we had already established that the schema worked for NextGen and it worked for everything enterprise-wide within the GIS department. So now we need to get our data up to snuff. So first, I tackled the critical errors. When you get a NextGen QC report, those critical errors are highlighted in red. And so that motivated me to get rid of those errors as quickly as possible. For those critical errors, NextGen provides, or excuse me, Geocom provides layers showing the location of those errors, which makes them super easy to find. So within that information, I looked for maximum impact. So for example, one of our critical errors was duplicated addresses. Well, here I've got a copy of that attribute table, and you can see that there's a lot of addresses at 1269 North Main Street, and that actually accounted for 34 of our duplicate address errors. So I started there, where I could have like the most maximum impact on those critical errors. So once the critical errors are pretty much gone, I focused attention on a 98% match between the alley table and the road centerline layer. But this is a little bit more difficult for me because the QC check results are in table format with no associated GIS layer. Being a GIS person, I'm extremely visual, and I needed that connection with the geography in order to be really effective in fixing these issues. So I did look for repetition in those error tables. For example, the no matching street name QC check would quite often indicate a problem with an entire road and everything addressed off that road. So I fixed those in bulk. Then I would double check our MTAG and our alley information and make changes as needed. For us, the difficult task was keeping our local alley table copy matching our GIS. that was always extremely difficult for me to remember to go and do that third step. I also look for obvious error repetition in the inside community QC check. As the alley to road centerline errors were fixed, a lot of the alley to address point issues were fixed as well. So other low-hanging fruit was addresses which are higher or lower than compatible ranges. Quite often we just needed to bump up a range a few digits in our data. Our big problem areas we still have today have been addresses which fall in a range gap and addresses which were found in different communities. We've apparently got several hundred phone numbers at addresses which were made up by citizens. We're talking about phone lines in sheds, barns, second phone lines into the same house, but are using a different address for some reason. We've also discovered several dozen Bell South telephone equipment locations that hadn't been retired from the alley table in decades. Same is true with payphones, most of which were removed years ago. Their phone numbers persisted in the alley table assigned to addresses that we didn't have in our system. And in those cases, we asked that the telephone company that number be removed, and those requests were met with mixed results. So in order to get that 98% compliance, we had to do some funky things. I'm sure all of us who have worked on NextGen 911 have had to get creative, and each piece app, I'm sure, has its own challenges. And I'll go through a couple of these here. This location here, we have 3 addresses which are located in Person County, but are only accessible through Orange County. And so those roads and those ranges were not in our county, but we had to extend our provisioning boundary to capture those segments of those roads that belong to the addresses that are in the county. We also had a dozen or so homes that are physically located in Virginia. And while they don't pay taxes in Person County, they've always received our emergency services, and most of them had a 336 area code versus the typical 434 area code in Virginia. We had to get creative and figure out ways to accommodate these abnormalities. I even found a home on a road that we didn't know about or have records for, and we wound up having to contact Virginia Department of Transportation for that information. So in this example, essentially the addresses in this area got addressed to Orange County sometime in the early 90s, and then they were addressed again by Person County in the mid-90s, and we didn't even have an agreement on the name of the road, and so we had to go back through Powellville documentation to figure out what the road was even called. So I mentioned earlier that I visualize things better than reading through a table. So I decided to rely on that strength and look for a way to visualize NextGen errors. So if you look at the map on the screen, roads that have a 999 in our GC exception code, so those roads that are outside of Person County and excluded from the analysis, they are shown in red on that map. And if they're shown in green, then they're roads that we're responsible for NextGen. So I basically have this MXD, I just open it up, I turn the layers on, and I look for any sort of symbology abnormalities. So that's kind of what I did for the roads. I did the same for our address points. So here you can see we have an unincorporated municipality with a couple of dots in red. On that left-hand map, in the middle map, Roxborough has green dots versus the pink dots shown out in the county. And so this is just a couple of examples of some of the simple visual checks that I have. I can basically just open up this map, turn all the layers on, and very easily see errors without having to look for them in the tables. This example shows how I used symbology to point out the MSAG community zip code errors I discussed earlier. Zip code polygons are symbolized by zip codes. Roads are symbolized by their MSAG community on the left and on the right. And addresses are also symbolized by their MSAG community. And so in the example shown, you can clearly see an error where I've got a blue road. Blue is for Sonora. in the yellow zip code area for Leesburg, North Carolina. And I found using this MXD and looking for these errors before submitting the geocom was actually a lot more productive for me. I'll skip over this really quickly. Discussed it earlier. We do use the address and street editing solution template from Esri for our addressing. We also use the attribute assistant, and between the two, it basically populates almost everything for us, populates the zip code and all that sort of information. So there's less possibility for us in data. So in summary, we used a stepped approach to implementing NextGen. We examined our existing schema for those operational dependencies, created a new schema, we loaded the data and implemented that schema enterprise-wide, and then we gained and maintained NextGen data compliance. If I had it to do all over again without the cyber incident and without COVID, these steps would have been pretty much the same. We just had the advantage of having our production environment not visible to the public while a lot of these things happen. So with that, I want to thank everyone for attending today. I know that was a lot of information all at once, and I'll be happy to take any questions. Thank you,
Sally. That was a great presentation, and it's great to see it from the county's perspective. We have some comments and questions that are in the chat, so I'll read those out to you, Sally. Tim Mangum made a comment that he's never heard of people making up phone numbers and addresses, LOL. So maybe he has. Oh, yes. I'm sure that happens quite frequently. I've heard that a lot. So Brittany Pendleton made a comment that regarding your Orange County example, that exact address was flagged for them as well. And hello from Orange County. So your neighbor there saw that come up. Danny Smith said a very practical presentation of the process. Thanks. He asked, how much of the Data Hub submission process have you been able to automate, and do you use Task Scheduler or a similar application to do that? That is a great question. I have not automated any of that. I would like to get, I know there's a very simple script that can be written that will export layers out of an MXD and put them in a common stored location. I do know that that is a script that I really should implement for a variety of issues. But beyond that, it's pretty much a manual process. It doesn't take more than 15 minutes each time. Okay, thank you. Mark Smith commented, great to show abnormalities with the data. And Josh Norwood also made a comment, amazing work, Sally, and thanks. If there are any other questions, feel free to throw those in the chat. We do have a couple of minutes. I did like that your use of the AGOL assistant. I've used that before, and that does save a great amount of time. It definitely simplifies updating your service URLs, and also you have those REST URLs documented now, and that's great for documentation moving forward, knowing where those are being used. Nick DiPaolo, sorry if I butchered your last name there, Nick, but he asked a question. Did you have situations with multiple units on one parcel, i.e. apartments in a building? And if so, how did you handle those? We absolutely do have that. We several years ago began addressing units versus just addressing buildings within a parcel. So duplexes, apartment complexes, that type of thing. You know, we've done everything we possibly can to collect all of those unit numbers. We had an audit many years ago now where a contractor drove around the county and documented a lot of that stuff for us. So we kind of knew where our duplexes were located. We had information from our apartment complexes about what their units were called. That is still a pain point for us. We've got about 650 more that we need to visit. And we've also found that the phone company, whether it's an apartment or a suite or a side to a duplex, they want to use the word unit. And so we've kind of had to go back and forth with them about what sort of standard are we expecting in that information. But yes, we have done that. And
I think it's worked out well for us.
Great. Well, thank you, Sally. I think that wraps up everything. Again, I appreciate your time and your work in putting this together. I know I appreciate it, and I know others as well. Sally's information's on the screen if you'd like to reach out to her, her phone number and email address. So I'm sure she'd welcome any questions you may have. Again, thanks, Sally, and stay safe up there in Person County with all the ice and everything that's going on, and hope power will persist and stay warm. So thanks.